In this video, I want to take that first example a little bit further, and also I want to fix a couple things here. But the first thing I want to mention is that the purpose of this one is to show some proof that the code is working the way I described it in the previous video. And to see all the code, I'm going to need to scroll that up there. What I'm doing in this example is almost exactly the same, so skip that function for right now. And if you look at the run value down here, you can see that I'm starting off with the same line right there. Then in this section here, I do 1,000 increments as I did before. And I'll show that in just a minute. I just want to show right now that I'm doing 1,000 increments, and then I'm doing 1,000 decrements, almost exactly the way I did it before, except I'm using a function for that. Then here at the end, I'm taking the increment variable that I have right there. I join that, and then I do a zip par with the decrement variable, and I join that as well. And this allows me to wait for both of those fibers to complete. And then, like I did in the previous example here, I have the counter value that we started with over here. I get that value, call commit, assign that to the res variable, and then print it out at the end. So I just want to note that everything from here to here is very similar to the last example, and so is this part here. The only thing I do different here is this portion of this code, and I noted in the previous video that I wasn't doing a join, and in this video I am doing a join and also showing zip par as well. So now we can look at the update counter function over here. So you can see the parameters that it takes. The first one is a counter. It's a tref of type int. The second value is an amount, and that's the integer. Third value is operation name, and that's a string. So you can see that's either going to be increments or decrements. Then I have a batch size and a batch number. And you can see how I use those here. The batch size for both of these is going to be 100. And then the batch number has to do with the 1 to 10 parameter there and there. So you'll see how this works in the output in just a moment as well. Next, if we look at the return value, you see it's returning nothing or a unit. And then inside of here, I have a for expression. And I made a couple of corrections in here. I think in the previous video, I used for each par, and I should have used for each par discard because I'm not getting a return value out of this code. And as I mentioned in previous videos, for each par discard is going to be at least a little bit more efficient than for each par when your algorithm isn't returning a value. It's also more meaningful to the next developer who comes along and looks at your code, and then they say, oh, okay, Al knew what he's doing here. He's using discard because this code down here isn't returning a value. So that was a first mistake. Even if it's a minor mistake, it was a little bit of a mistake. Then inside there we have 1 to batch size, and that's similar to what we had before, except now I'm just using a variable here. And when we come down here, batch size is going to be 100 in each case, so it'll be from 1 to 100 right there. And I should mention that in both cases when this is called, the algorithm is going to be a plus operation right there. And the way the increment and decrement works is that in this case, I pass in a positive one, and in this case, I pass in a negative one. So this one gives us the decrement value when it's used with addition right there. Oh, also, I need to note that in the previous video, I used update and get, and that was wrong. I shouldn't have done that. I should have just used update. There's no reason to get, or for this particular algorithm, there's no reason to use update and get. I'm just updating it. Really, I think what I did was I was so eager to show transactions. I wanted to show something that was doing more than one thing at a time. I think that's why I did that. But anyway, update is more correct than using update and get. And I should say that the effect of this code right here is that we're creating this batch size going from 1 to 100. So we're running 100 instances of this algorithm right here, and we're doing that in parallel with for each discard. And again, the reason I know it's 100 is because there's 100 here and 100 here. But the thing I need to add to that is that I'm doing that 10 times here and 10 times here. So I'm doing 10 times 100 for increments, and I'm doing 10 times 100 for the decrements. And the reason I'm going through this extra work was just to make this example a bit more complicated than the previous one. And now I should come back here and finish describing this function. So here I do the same thing I did before. I call get on the counter and do a commit right there, and that's the value. And what am I doing? Oh, okay, I'm sorry. In this case, right here and here, what I'm doing here is printing a little bit of debug information as we go along. So let me save that, make sure we have all those changes, and run this so you can see what's actually going on here. And there you saw how fast that ran. So the debug information I was talking about is coming from here. So you see after 1,000 decrements, we have minus 16. After 1,000 increments, minus 301. And all of this information over here that says after is coming out of this debug line right there. So as we go along, the important thing down here is that we end with a final counter value of 0. So if you go back up here and look at this column, you can see that all these print statements are out of order. But the only thing that matters because of our algorithm is that the final counter value is printed at the end of the algorithm. And again, that final counter value is 0, and that's exactly what it should be because of the increment and decrement operations we're performing over here. So again, all of this code here, along with this output over here, was intended to prove to you that TREF is working the way I described it. And I believe that if you take the time to run this code on your computer and look at the output and come in here and change anything that you want to change, give yourself more increments here or more decrements or change these values, really change anything you want on your own computer to prove to yourself that things like TREF and commit and for each par and for each par discard and all these other things, prove to yourself that all of these things are working the way I described them.